All right. Hi, everyone. Today is Wednesday, December 16th. It will probably be a little while before you see this video. So hopefully your new year is off to a good start. Right now, you should have already downloaded and uploaded into Notability your new chemical reactions packet. That pretty much has what you need to have to do your next unit. There's some really good helpful hints in there, some really good helpful sheets in there. In particular, talking about this cheat sheet, it kind of goes over everything that you need to have, okay? So I'm here to talk to you today about the first type of reactions called synthesis and decomposition. So in a chemical reaction, we've already studied chemical changes, and chemical changes are chemical reactions. You have things coming together, bonding, and then forming something new. And then they break up their bonds, and then they bond with something new, and then form something new. And so there's basically 5 types of reactions that we're going to study here in chemistry. There's more. If you move on and take other chemistry classes, there'll be oxidation reduction, there'll be acid-base neutralization reactions, but we're not going to talk about that today. Today, we're going to talk about synthesis and decomposition. They're opposites of one another. So if you look here, we have in a synthesis reaction, 2 or more reactants come together to form one compound. All right, so some vocabulary that you need to know about when you are doing this, okay? So what happens is you have the reactants on one side, and then the arrow points to the products. So those are 2 words that you need to familiarize yourself with. We will use that a lot here coming forward. This arrow can sometimes be referred to as yields or produces. Those are all words that are used in chemistry, okay? So sometimes you can have a reactants. Sometimes there can be multiple things coming together to make products. And sometimes you can have one product. So today, what we are going to learn about is we are going to learn about the first type, where you have an element plus an element. And when they come together, they are going to make a compound. And this type of reaction is called synthesis. Okay, another word for it is combination. Okay, so that's our first type. Another way of looking at this is I have this cute little diagram here, drawing, where you have, looks like a gentleman, right? We're gonna call him A. Sees a cute girl, we'll call her B. She's a single person, a single element. Elements are one thing, right? And he kind of does this like double take. You can see these swoosh things. So it's like she walks by and he's like, whoop, you know, cat calls to her. And they end up forming this beautiful thing together, this love relationship where they are chemically combined together. Okay, so we would call this type of reaction a synthesis. Oops, synthesis. Another word for it is combination or combo. Okay, so that's the first type of reaction. And then we have basically the opposite of this. I think a lot of you as high school students are probably pretty familiar with this one, unfortunately. You could be in a relationship with somebody. You know, you are in this little, you know, love affection thing. But in a decomposition reaction, you end up going this way. So we'll make my pen a little thicker. And in a decomposition, you are in a relationship and all of a sudden you break up, okay? So when we go the opposite way, that is called a decomposition, okay? So decomposition is, and you can often abbreviate this as decomp. Decomp happens when you have a compound which is 2 or more elements, chemically combined together. Break up into smaller pieces. Okay, so just like we have in here, we have a compound, AB, and that breaks down into its separate parts, A and B. Okay. So one of the things that when we do this, you have to be pretty cognizant of is what's called diatomics. So you know how I told you that this guy is kind of all by itself, and then I told you that this girl here is all by herself, right? I told you that was the case, right? She's all by herself. Well, it just so happens in chemistry that there are elements that can't be by themselves. You all know who I'm talking about. There is that girl or that boy that jumps from relationship to relationship to relationship, and they cannot be by themselves. And so these elements are called diatomics. Maybe you can see them here. They're called diatomics, okay? And what that means is these elements are not found in nature by themselves. They cannot exist on their own. They have to be chemically combined with themselves. And so there's a couple different ways you can remember them. They're all gases, and here's a list of them. We can, show you them here. So there's that list is right here. Another way to think of them is if you look at the periodic table, they're also called the sneaky 7. So they make like a 7 on the periodic table. And then you have hydrogen over here, okay? But the most common way that you will refer to, I will refer to them, is this phrase called Burr, Hahn, Fickle. Okay, so made up word. It's a word that I kind of came up with as a way for students to remember diatomics. So what that means, if bromine is ever going to be in any chemical formula and it's standalone, it's not chemically combined to anything, you have to put a Br2 by it. Okay. If hydrogen is in a chemical formula bonded with nothing else, it's just hydrogen all by itself, you have to put a 2 by it. Same goes with oxygen, nitrogen, fluorine, iodine, and chlorine. These are called the diatomics or Behn-Fickles, okay? So what do I mean by that? Well, let's take a look at some of these problems down here. Calcium is Ca. It's all by itself. It's not bonded to anything because here's the plus sign. So I really want you guys, when you are doing this, to line everything up vertically. It's going to be so important when you go to organize all this stuff because it's going to get a whole lot more complicated than these, okay? So right below the word calcium, I want you to write the symbol calcium. Then, just like I've done here, here's my, plus sign. Right below that, I carry my plus sign. Keep everything lined up vertically, okay? Now, right below oxygen, I'm going to write the symbol for oxygen. Now you need to be careful with some of these because remember, oxygen is over here. It is one of my diatomics. I'm highlighting it here in the red laser pointer. And so what that means is because it's just oxygen here by itself and it's not bonded to anything, I have to make sure I put a 2. Okay, just like that. And then when I go to chemically combine them, remember in our last unit, see how everything's starting to build? Hopefully you get this here. In our last unit, when we make compounds, you have to crisscross charges. So it's important that you understand that you kind of need to do a little intermediate step here. You're probably going to want to make sure you go on the periodic table and you find calcium. Calcium is right here. Okay. And go up to the top and figure out the charge. And the charge is a +2. Then you're going to want to do the same thing for oxygen. Oxygen on the periodic table is a -2. And then what you need to do is crisscross those charges. Remember, this 2 is going to want to, this 2 is going to want to come over here. And this, like that. And this 2 is going to want to come, oops, and this 2 is going to want to, why doesn't this always work? It's so irritating. This 2 is going to want to come over here. Okay. But you're probably yelling at the screen right now saying, Ms. Sundberg, no, they don't crisscross because they cancel. A positive 2 and a negative 2 cancel. And so you end up with a formula of CaO. Now, some of you may be like freaking out and wondering, well, if there's 2 oxygens over here, I better have 2 oxygens here. So a lot of you will be tempted to write a 2 here. Please don't do that. We will get to balancing, making sure there's equal amounts on each side in our next unit. So it is coming, but just be okay with there being more oxygens on the reactant side than the product side, okay? Now, here we have a compound. How do I know it's a compound? There is no plus sign here. So I'm going to take this compound or a couple and I'm going to split it into 2. How I split it into 2, it gets split into calcium and oxygen. So it's almost exactly like we just did on the previous one. But remember, when you have a compound, you have to crisscross charges. When there's no plus sign, like here, to separate the 2 elements, you have to crisscross. So I'm going to take calcium is a Ca with a +2. Oxygen is O with a -2. So my formula now is going to be CaO because the +2 cancels with the -2. I then keep everything lined up. I bring my arrow straight down. Okay, keep everything lined up. Right below calcium, I'm going to write the symbol for calcium. So Ca. When it's an element, I don't have to worry about charges. You're by yourself. You're not crisscrossing charges. You're not doing anything. You don't even have to write a charge when it's just an element listed. Okay. Followed by, I got to bring my plus sign down and then line up next oxygen. Bring my oxygen down. The symbol for oxygen is O. Now, when you have elements all by itself, just an element, nothing bonded to it, calcium, it's just calcium. I want to go up here and check and see if calcium is one of my diatomic Bernoulli. And calcium's not, so I can just leave it Ca. Now I want to go and check, is oxygen one of my diatomic, one of my Bernoulli? Go up here, oop, oxygen is. And so when that happens, you have to have that 2 there, okay? So what is my final answer? This is what I'm looking for, okay? All right, let's do a couple more. Next, again, I have a compound here. This compound is zinc 2 sulfide. Ooh, back to some of that naming stuff that I told you is not going away. So zinc and has a Roman numeral 2 by it, which means zinc is Zn. And because this is a Roman numeral 2, that means it's going to have a +2 charge. That Roman numeral has to match the charge on zinc. Okay, moving on. Sulfide. It ends in IDE, sulfide, which means it's going to be on your periodic table as a non-metal. So I'm going to look up sulfide. Sulfide is a -S with a -2. Again, I look at these charges. I would crisscross charges, but in this case, I don't have to because they are direct opposites of one another and they cancel each other out. So my formula is ZnS. Notice how I kept everything lined up. I did not write ZnS over here. Everything goes lined up in a vertical column. That's going to be so important. I can't stress to you how important that is when we move forward to do single replacement and double replacement reactions. Okay, line everything up vertically. Then we're going to move on and predict our products. So if I have zinc and sulfide and they're coming together as a compound and they're chemically combined, and they get in a fight and they, want a divorce, they're going to break up into their original parts, zinc and sulfur. So I want to write this out in names, oops, zinc, and then I have to make sure I include the Roman numeral, and sulfur. Now, remember, it's not sulfide because you change the ending once you become chemically combined or married, right? Okay, so now line everything up, zinc goes right below it. Zinc, I don't need a charge. It's only zinc. Zinc is zinc. I don't need to put a charge on it. It is what it is, okay? I'll line up my plus sign. and then line up sulfur. Okay, now, anytime you have an element, just an element listed, one box from the periodic table, please go up and check your Verhanfinkels, your diatomics. Is zinc one of them? And if you can say no, leave it, don't put any number. Leave it, don't put any number here. Okay, go up here. Sulfur, is sulfur one of my diatomics? And it's not, so I do not have to put anything here. And this is my final answer. Okay. All right, let's try this one. Number 6. And so number 6 says hydrogen plus nitrogen. So you have the plus sign. The plus sign is huge. You have A plus B, and you know you're going to get an AB on this side. So it's like a single person, and then they're coming together to make a compound. There's no more plus sign separating them. Okay. So when hydrogen comes together with nitrogen, maybe you remember when things start out with hydrogen, remember they make an acid, right? Hydrogen makes an acid. So over here, you're going to have some acid of some type, okay? So when you have hydrogen combined with nitrogen, so we're going to have hydrogen with a, it's just hydrogen. And then I keep my plus sign all lined up. Again, I can't stress to you how important that is, okay? And then you have nitrogen. Again, keep everything lined up, okay? Nitrogen, you will end up getting a compound where you have to crisscross charges. So I know hydrogen's charge is a +1, nitrogen's charge is a -3. So when I crisscross those charges, I'm going to end up with a formula of H3N. Now, what's the name of that? Well, because it starts with an H, it's an acid, which I already have the name here, okay? And because it's just N, which means this used to be nitride with an IDE ending. Okay, so I'm just going to write that off to the side. That means because it had ide, it becomes hydro, nitric, oops, I'm running out of space here. I didn't space myself out very well. Nitric acid. This IDE ending gives you the hydro, gives you the ic and the acid. Okay, that's the hard part. You got to remember that last unit, that acids that we talked about before winter break. Okay. If you need any help renaming or learning naming again and getting caught up with naming, I suggest you go back to the Unit 5 folder, the naming bonding folder, and watch some of those instructional videos to get a refresher. Okay, hopefully this helped, and I will see you guys later.